lowest common ancestor of deepest leaves. So for this problem, we are giving the root of a binary tree and we're going to return the lowest common ancestor of its deepest leaves. So let's try to understand what is the deepest leaves. So for the deepest leaves, let's try to understand from here. So the node of a binary tree is a leaf. So the node of a binary tree is a leaf if and only if it has no children. So for example, 7, 4, 6, 0, and 8, those nodes are the leaves. But what is the deepest? So the depth of the root of the tree is 0. If the depth of the node is d, the depth of each of the children is d plus 1. So this means, for example, if the depth of this node 2 is 2, because this root node is 0, and this is 1, this is 2. So for the children, for this 7 and 4, it's going to be 3. And 7 and 4 are going to be the deepest leaves. Yeah. So if we understand about here, normally we can solve the problem. So the lowest common ancestor of a set S of nodes is the node A with the largest depth such that every node in S is in the subtree with root A. Yeah, so the meaning is that first of all, we're going to find the deepest leaves. So for this example, it's going to be 7 and 4. And then we just need to find the lowest common ancestor. And so for this 7 and 4, the lowest common ancestor is going to be this node 2. So this is why we're going to return node 2. Yeah. So how can we solve such kind of problem? First of all, we're going to find the deepest leaves, and we can use a BFS to find the deepest leaves. So we should know that 7 and 4 are the deepest leaves. And then we're going to use DFS to calculate what is the lowest common ancestor of two nodes. So for example, if we were to calculate the nodes 7 and 4, so what is the lowest common ancestor of 7 and 4? Definitely it's going to be 2. So this is going to be another DFS. We can calculate that. Yeah. So maybe we have more nodes at the leaf. Maybe after 0, there's going to be a node 9, and there's going to be a node 10. So currently, we are going to calculate what is the lowest common ancestor of those 4 leaves, because we have 7, 4, 9, and 10. So definitely it's going to be 3. But how can we calculate that? So we're going to calculate 2 by 2, because in Leetcode, I think there's a problem about how to calculate what is the lowest common ancestor of 2 nodes. So for example, currently we have 4 nodes. How can we get that? We're going to calculate 2 by 2. For example, first of all, we're going to calculate 7 and 4, so we're going to have a node 2, and then we're going to calculate 2 and 9. So what is the 2 and 9? It's going to be 3. And what is 3 and 10? What is the lowest common ancestor of 3 and 10? So it's going to be 3 itself. So for this problem, actually, we can solve it by using 2 easy problems. We're going to use a BFS, and then we're going to use a DFS to solve the problem. Yeah. So first of all, let me define the lowest common ancestor of 2 nodes. So I'm going to prepare a node with P and Q, and we're going to check if node inside P and Q. This means if node equal to P or node equal to Q, so we're going to return the node. So if the node does not exist, we're going to return a none. Yeah. So this DFS function is just to check what is the lowest common ancestor of 2 nodes. So we're going to prepare a left and a right. It's going to be DFS node dot left with P and Q, and DFS with node dot right with P and Q. So we're going to check if left and right. So we're going to return. So if the left and right exist, so we're going to return the root node. So we're going to return this node. Otherwise, so we're going to return left or right. Yeah. So this is going to be the DFS to calculate what is the lowest common ancestor of 2 nodes. So for example, 7 and 4, it's going to be 2. Now I'm going to define a BFS function. So let me define it here. So for the BFS, first of all, I'm going to put a Q as the Q inside. I'm going to give the root node. Now I'm going to execute the level order traversal. So while Q and prepare a level Let me check, do I need to have this level or not? Yeah, I have. Let me just prepare a level, and for anything in range length of q, so I'm gonna pop out the node. It's gonna be equal to q dot pop left. So if node dot left exists, so q needed to append node dot left, and if node dot right exists, so q needed to append node dot right. Yeah, so in this way, this is just the level order traversal. So currently we just put everything inside of the queue. I don't think we need this kind of level. Let me prepare. Yeah, so I don't think we need this kind of level. Let me prepare a result gonna equal to list of q, and finally I'm gonna return the result. So for this function, actually this is just to check what is gonna be the last level of the binary tree. So first of all, we're gonna assign this result to the queue. Currently we have this 3, and then we're going to execute the level order traversal, and we're going to pop out the node 3, and we're going to put 5 and 1 inside, and the result is going to equal to the list of this queue. And then I'm going to execute it. So while the queue exist, so the result gonna assign to this queue, it's gonna be 7 and 4, and then I'm gonna pop out, and inside it's gonna be nothing. Yeah, I think this should be okay. So now I have a result array. It's gonna be the last level. It's gonna be the deepest level for this node 7 and 4. Let me just execute the BFS. Let's just check what is inside. Let me return a noun currently. Yeah, let's just check this BFS if it works. Yeah, it seems for the BFS it didn't work. Let me just check. Yeah, I think I need to prepare a level array, and this level gonna append the value. Yeah, let me just use this level. Yeah, because currently I get a result, but the result gonna be popped out. It's gonna be an empty array. So I need to yeah, let me just use it this way, maybe. So let me prepare the level. So the level gonna equal to q, and the result gonna equal to the list of level. Yeah, let me just use this way, maybe it should work. No. Yeah, let me just check what is inside of the queue. Yeah, let me just print out what is inside of the queue, maybe. Yeah, there's something inside of the queue. Yeah, definitely it should not work, and this one should be the list of the queue for the result. But I didn't use the level actually. Yeah, I think this is just a level order traversal. Let me just check that. While q, so the result gonna equal to the list of q. Yeah, let me just write it like this, maybe. the level gonna equal to Q, and this gonna be the list of level. Yeah, let me put it here. Yeah, I think it's the same. Basically, inside of the queue, it should be empty. Actually, I would to have the last layer. If I were to write it like this way, yeah, so if there is a result, I need to have this result as the list of queue. And finally, I return this result array. I think it should be okay. But there's nothing inside of the result. Let me just print out the result to check what is why there's nothing inside. Yeah, it seems that there's something inside of the queue. It should be my final result. Did I do something wrong? Yeah, I think it should be print out what is gonna be the result. Let me just check the result. Yeah, because this result must be the last layer of the queue. Let me just print it out. Yeah, I think it should be okay. As you can see, it's gonna be the node 7 and node 4 for the last layer. Yeah, I think it took me such a long time because I forgot to print out the result. That is why I didn't say anything, because I forgot to print out. Now I think the BFS should be okay, and this DFS I just need to check if it works. Yeah. So I'm gonna prepare an answer. It's gonna be the result 0, and I'm gonna loop through for I in range from 1 to length of the result. So I'm gonna check 2 nodes by 2 nodes until I find the lowest common ancestor of all the nodes in the deepest level. So I'm going to prepare this answer. It's going to be the DFS with the root node, and with the answer currently it's going to be result 0 and result 1. So it's going to be result I, and after that I'm going to update this result I until I get the answer. Finally, I just need to return the answer. Now let me just run it to check. As you can see, it works. Now let me just submit it to prove it should pass for all testing cases. Yeah, as you can see, it passed for all testing cases. Let me submit it again. Maybe it's going to be faster than before. As you can see, it is much faster. Yeah, so this type of problem, normally we're going to use BFS with DFS. I think it is still a good problem. And basically, the DFS is just like while we are calculating the lowest common ancestors of 2 nodes. And this BFS actually is calculating the last level. And this kind of loops is just to